Understanding how osteoclasts work in orthopedics is fairly key because they're implicated in a whole host of processes, including remodeling of normal bone, calcium homeostasis, a whole host of metabolic bone disorders, and osteolysis and loosening. So first of all, active osteoclasts, they come from the inactive form, which is a mononuclear kind of precursor, osteoclast precursor, which is usually inactive. On the surface, this expresses rank, which is a receptor for rank ligand, which is usually expressed by osteoblasts. Now, when they express the rank ligand attaches to the rank, and this fully activates the osteoclast to become a multinucleated giant cell in its active form. Now, usually these osteoclasts sit in these little dips in periosteal or endosteal bone, and these little pits are called Howship's lacunae. Now, within the osteoclast itself, there are various other components. They have an abundance of mitochondria, and also they have lots of lysozyme as well. Now, these osteoclasts have a ruffled border. Now, this ruffled border increases the surface area for the resorption to take place. And the ruffled border at the edges of the osteoclasts are anchored, and this seals the osteoclast in its Howship's lacunae to be able to produce almost like a watertight area to allow the pH environment to become more acidic. And these sealing zones are anchored in via integrins. So how does it actually make the area more acidic? Well, it releases hydrochloric acid and H+ ions via the carbonic anhydrase system, and this is usually ATP driven, making the process, the area more acidic. It's the hydrochloric acid and the reduced acidity of this environment which dissolves the majority of the inorganic matrix of the bone. And from my previous video, as you know, the inorganic matrix is mainly derived of hydroxyapatite. To resorb the organic matrix, it releases proteolytic enzymes called tartrate-resistant acid phosphatase, or TRAP, and also camptothecin K. Now, these are produced by the lysozymes and the mitochondria, and these dissolve the organic matrix, extracellular matrix, and the organic is mainly collagen type 1, your proteoglycans, and your other proteins. So this is largely how osteoclasts resorb bone. Now, you may be asked also, how do bisphosphonates work? So largely bisphosphonates, you'll need to know, are largely divided into nitrogen containing and non-nitrogen containing, but they essentially have two functions. The first function is that they directly stabilize the hydroxyapatite crystals, making them less soluble to allow the acid environment to resorb the calcium hydroxyapatite. The second function is that it prevents the formation of the ruffled border of the osteoclast and induces apoptosis. And it does this via the mevalonate pathway through inhibition of farnesyl pyrophosphate, which is essential for the formation of the ruffled border.